Hello, welcome and a very good evening. And today we want to do another Let's Code for the ESP8266, or in my case at the moment it's the ESP32 Dev Kit board, and you probably have something similar at home. I'm mostly using the ESP32 now because, let's face it, it isn't that much more expensive than the 8266, but so much more powerful. And today's thing will run on both systems, but if you don't have the ESP32, you don't have to worry. Anyway, today I want to check out this little breakout board here. I got it from a friend. He got a few of those for free, and I thought, well, it might be an interesting thing. It's a humidity and temperature sensor. And it says here SI7021, and if you search for libraries for the SI7021, you will find loads on the internet for the Arduino, for the ESP and similar devices. So it's a very common device interfacing with I2C, as you can see by the SCL and SDA pins here. And yesterday I coded after a tutorial that I found on the web. I looked at the datasheet for the SI7021 and I almost went mad because it wouldn't tell me its firmware revision. But as you can see, if you look very closely here, the chip actually doesn't say SI7021, plus the silk screen says SHT21 and HTU21, although it looks like HTV. And further Googling or searching the web returned that the SI7021, the SHT21 and the HTU21 are basically all the same chips by different manufacturers with slightly different features. And this one here, this little breakout board, has the HTU21. So some commands are not supported on this one, and we will have a look at the datasheet in a second. But never fear, all the libraries should work more or less because they don't care about the firmware revision, and the temperature and humidity commands, they should work on all the chips. So let's look at the wiring. This is pretty standard stuff. Down here, I'm gonna pick it up a little bit. Down here we have 3.3 volts and ground, which will go to the VIN and ground pin of the breakout board. SCL and SDA are on the ESP32 Dev Kit on D22 and D21. D21 being the data line, and the yellow one, D22, is the clock line. Yeah, and I modded my board as well with the hack to have a capacitor between ground and enable. Otherwise I need to press boot to be actually able to flash this thing. Yeah, not sure why this works or what it's about, but I noticed mine wouldn't let itself flash, except I pressed boot upon flashing. And you can Google this, there's stuff on the internet explaining, yeah, put a capacitor in between those two pins, which I did. And we can fire up the device. It has nothing, an empty sketch on there at the moment. We'll have a look at the datasheet of the varying chips, and then do a little bit of coding after the tutorial that I did yesterday, and we will enhance it a little bit with a few commands. So yeah, let's get started. So looking at the different datasheets, we have the SiliconLabs SI7021 on the right side here, which should look like this, and it definitely doesn't look like the chip that we're having. And we have the measurement Specialties HTU21D or 21DF, which looks like this, and this definitely looks like the chip that we are having. They are both basically the same kind of chip for relative humidity and temperature. They both have the I2C interface, and they also use the same commands basically. which you can look up actually here in the chapter 5 of the SI7021, and you see it only has a few commands, most for measuring relative humidity and temperature, some reset command that we will implement, and also read firmware revision, which is the command that this one here doesn't have. Let's see if it has. No, it doesn't have a table of contents, so let's scroll down and see where it has its different commands. Here is the I2C interface. As you can see, for example, trigger humidity measurement is exactly the same, or F5 with no hold master. It also has a write user register and read user register, as well as the soft reset, but no mentioning about the electronic ID, which is the serial number. And yeah, but that one is actually supported, and we will see that in a very short while. The question now is, why do people choose one over the other? I guess it's mostly down to cost, which one is cheaper. And there is even a third chip, and I looked them up on Mouser. So on the left here we have the SiliconLabs SI7021, and Mouser gives you one from $3.06 if you buy one. And if you buy 1000, it's $271. But you can see that the measurement specialties is more expensive if you buy it in single pieces, $396. But already, if you buy 10 of those, you're already cheaper than if you buy 1000 with SiliconLabs. So obviously, people will go for the measurement specialties. The third chip here is the SHT21. And let me zoom out again. And you can see this is much more expensive. I'm not sure why. Maybe it's higher accuracy or something. But this is $750 for a single one. And yeah, even if you buy 100, it's twice as expensive as the cheap measurement specialties version. So there you have it. People choose the cheapest chip they can get, and they are pin compatible and protocol compatible to a certain degree. So that's why it happens. Here we have an empty sketch. We will need to include the wire library, which lets you talk to I2C devices. This is box standard Arduino programming, and we are using the Arduino IDE here because I think it's the easiest. You can port it to other boards later on, and it's better than I think it's better than to use the original ESP stuff. And we define the address of the SI7021, even we don't have it, but we still call it the 7021. And the address on the I2C bus is hexadecimal 40. And we will code a convenience function called wireEnd, because usually you will have something like wire.end transmission, and usually you will leave it at that to end the transmission on the wire. However, some people don't know that this actually returns something. It will return an error code, and we will call this an unsigned character error for error. And so we can see if there was an error on the I2C line, which happens, for example, if you send an unsupported command to such a device, and this will happen with the aforementioned firmware revision request. So if we have an error, then we will print that to the serial line by just writing error and then the error code. Let's make that a print line to make it more nice and readable, and we will also return the error code. So it will return false if there wasn't an error. Does it make sense? Let's put not error, so it will return true if there was success or false if there was an error, which is more intuitive, I think, because error will be 0 if there was no error. Okay, that's fine. Now the setup routine. We will use this error value later, and we will also need some data to be read, and we need to initialize the serial monitor so we can see our logging on the right hand side here in the window. And I noticed I need to delay by a second or so that the monitor can catch up, or we won't see the first line. But yeah, that's only a minor problem. Also, we will initialize the I2C protocol here with wire begin, and then we will try to reset the chip as a first test. It's not strictly necessary because the chip will just work when powered on. But it's nice to do it anyway, because then we will see if we wired everything up and it actually works. If it doesn't work, we will get an error and we know something's wrong. Either the chip is broken, we wired something up incorrectly, or some other problem right away. So we will begin a transmission to the SI7021 or compatible chip. And I will indent it here to show that we are writing stuff inside this transmission. And the reset command, according to the datasheet, was 0xFE. And then we will call our wire end, and we will already see an error if it doesn't work. I will also introduce a delay of 100 milliseconds here for the after every transmission. There should be less time needed for most commands, but I figured out that 100 is basically what works best, and we only want to sample like once a second or so, so that's no biggie if we delay for 1/10 of a second. Let's try if this works, if we coded any errors here, and see if we can reset the thing. Yep, there is something wrong. I forgot an equal sign, an assignment. Try again. So that's something I'm still missing from the Arduino IDE, that it does on the fly checking. Let's see if the serial port works, because after a few minutes it usually, or after a couple of flashes, I have to reset the whole thing. And it says starting up, and there's no error code, so it should be working. No error code from the end transmission. I think that's fine. Yeah, now let's try to get the firmware version, because that should give us an error. Get firmware revision. On this chip at least. If you have a genuine SI7021, then you should be fine. But for proof of my theory that it won't work, we will code this. So we will do another transmission to the 7021, and if you look into the datasheet, you will see the command was 0x84 followed by, so it's 2 bytes, 0xB8, and then we will catch the, do we call it error? What did we say? If, let's call it success, that's more sensible. Success equals wire end, and if there is success, then we can actually request the firmware revision byte. And this works by calling wire request from. We give the address again, we tell the chip, yeah, I want 1 byte please. And if something is available, 1 byte exactly, to be specific, then we can actually read this, and that's what we needed the data variable for, wire.read, and we can print the firmware version, serial print. We print it in hex because there's only 2 values possible. It should be 0xFF or 0x20. This 0xFF is version 1.2 and 0x20 is firmware version 2.0. If you have an original chip, but it will not work for us anyway, which is sad. Does it make sense to put a print line here? Probably. I'm just gonna put one here. Otherwise, we will comment saying something along the lines of a firmware version command not supported. So, a lot of noise for my chip here, but if you are using it with an original chip, it should be fine and actually helpful, I think, to figure out which revision you've got. Let's see if the device still works. Yeah, it still works, that's nice. And we're getting an error. Okay, this probably was a bit stupid, a little bit stupid, because the firmware revision command were not supported. Doesn't work, but this will work. Meanwhile, we can already continue to code. We could do other commands as well, like the readout of the serial ID, but I'll leave that up to you. It works in a similar fashion, but it gives you more than 1 byte and you need to issue 2 commands. Yeah, here you go. I will put the code into the GitHub repository, but won't code it here. So have a look in the video description. There's everything you need if you just want to get started. And yeah, the more interesting part is to read out the actual data, and the data for humidity and temperature come in 16-bit values, because 8-bit would be a little bit too coarse. And we will do the humidity measurement first. And again, we will do a transmission towards the chip. And the command for that was 0xF5, very simple. And we can do the wire AND again. It will log an error if it doesn't work. I will also do the delay here, which is important, otherwise the results will be very skewed. So there's an analog to digital converter, actually, yes, that samples these values, and it takes a bit of time to sample them in high enough resolution. And if you don't do a delay here, you will get completely garbage values. Yeah, you can play with the values a little bit, but you will see that they diverge very quickly if you go lower than 100. After the delay, we can read back the values, and it's, as I said, a 16-bit value, so 2 bytes to be read. So we ask the wire, are 2 bytes available, which almost always should be the case. And then we can simply read them byte by byte. Wire.read, and the second one, wire.read. The second one, I'm funny. Data 0 and data 1, of course, reading into the data buffer. And then we can use, first of all, an temporary variable called TMP, and we can use the formula from the datasheet. The datasheet tells us that there is the two bytes, well, they don't send individual bytes, they say they send a 16-bit value, so we have to convert it. This is the higher byte, comes first, so we have to shift it left by 8 bits, and then add the lower byte to it, which converts it to a 16-bit value. And then the humidity is actually calculated by multiplying this temporary value by 125, and I'm doing the 0.0 here to force the conversion into floating point. Then we will have to divide that by 65,536, that's 2 to the power of 16, because it's 16-bit value, and this is basically a normalization of that. And that result we have to subtract by 6. This is kind of a calibration thingy for the chip, but all the chips use the same. The temperature goes almost the same. Temperature measurement works almost the same. I will copy the whole thing here, and the command is different. The command is F3, and the conversion is slightly different. So the conversion, first of all, the temporary value conversion is of course exactly the same, because it's again a 16-bit value, and the temperature, temperature in Celsius, let's call it this, is a scaling again, 175.72 times our temporary 16-bit value. Then it has to be normalized again by the 2 to the power of 16, sorry. And then we have to adjust it as well by some value, and that value from the datasheet is 46.85. This gives us the temperature in Celsius, and you can calculate it in Fahrenheit as well or whatever, but this is the formula given in the datasheet, so I'll stick to that. So we can print out the whole stuff here. Humidity is the following. Yeah, just put it like this. This is in percent relative humidity, and we called it, what did we call it? Humidity. That's it. And then we can also print the temperature in, do I have a degree sign? Yeah, degree Celsius. That's good. Print line Celsius temp, and we will delay for 1 second to not spam either the monitor or the other thing. Let's see if that works actually, because we wrote quite a lot of things. Okay, we have a few problems, which is fine. Namely, I mistyped this one here, and probably also mistyped the one below, I guess. Yes, there we are. One extra bracket that we don't need. And the question is, well, this looks good, I think. Looks excellent. Let's see if it can flash or if the device crashed. Yeah, the device crashed more or less. I have to pull the plug, reattach it, then it will work again. I have no idea why, but I can live with that. This happens only every couple of minutes. It's a bit annoying, but yeah, I don't know. So let's see, it compiles, it connects, it's hopefully uploading, yes. And then let's take a look here. Starting up, and firmware version command not supported, but we have relative humidity of 51%, and temperature is supposed to be 23.67 degrees. Let me put my finger on that and we should see a significant rise in temperature. We're up to 26, 27, 28, 29 degrees. Yeah, let's see if I have a fever, if I have corona or something. I hope not, I'm feeling rather well. But as you can see, it's working. We didn't need any external library. The tutorial I based this upon was very excellent. It showed very nicely how to do this with the Wire library. And the datasheets actually tell you everything you need. So reading the datasheets of the chips is actually a good exercise, I think. So let's take the finger away. We have high relative humidity as well. Now due to my fingers being a little bit sweaty, I guess, or capturing some humidity in there, and it drops down significantly, as you can see, 38% only, which is far lower than it was reporting in the beginning. Going slightly back up. Yeah, it's interesting. You can build your own monitor now, send the data somewhere, use a web interface to publish it, or MQTT, or whatever you like. But for today, I think that's it. I hope this was useful. I will put all this stuff on GitHub and put a link into the video description. And I hope to see you soon. Please subscribe if you haven't already. I have mostly retro PC content, but once in a while I'll do some more modern stuff like this. And yeah, leave a like or a dislike depending on what you thought about this video. Definitely leave a comment or some discussion. If you want, you can support my channel over on Patreon, on PayPal or Ko-fi. If you can't support me where this means, it doesn't matter. I'm happy that you're here and I hope to see you very soon. So have a very nice evening.